This is chapter 6, understanding data step processing. The content of this chapter are writing basic data steps, how SAS processes program, compilation phase, execution phase, debugging, testing, and so on. So creating SAS data set from an external file is chapter 5, just before that. This chapter talks about behind the scene, how data step reach your data. We'll examine the data vector, which is the logical framework that SAS uses when creating SAS data. Now, raw data file invent. You have input item ID number in stock and backforward, and you have a fixed width kind of a setup. On the top you have this scale which is written 10 and 20 and dot 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 dash dash dash. Run. Program data vector n equal to 0, error equal to 0, item is equal to 6 class marks, ID number in stock, back order, total 18. So in stock is 6, back order is 12, and total is 18. Then you have SAS data burn update item ID number in stock, back odd. You have 6 and 12. So in stock is 6, back odd is 12. Okay, back odd, I think that's the last one. Okay, total is 18, item ID number. This is what went inside. Understanding how the program operates can help you anticipate how variables will be created and processed, to plan your modification and interpret and debug program error. It will also give you useful strategies for preventing and correcting common data step errors. Objectives. In this chapter, you'll learn to identify two phases that occur when a data step is processed, interpret automatic variables, identify the processing phase in which an error occurs, debug SAS data steps, validate and invalid data, test programs by limiting the number of observations that are created, flag error in the SAS log. Writing basic data step. Creating SAS data sets from external file. Explained how to write a data step to create a permanent SAS data set from a raw data that is stored in an external file. Data clinic.stress in file test, input ID 1 to 4, name tolerance 45. There's a lot of things. This is partial raw data file test. You learn how to submit the data step and how to check the log to see whether this thing. So this is the log, this is the file name, file size, last modified, and 8 records were read from the in-file test. Maximum was 45. The data set clinic stress had 8 observation and 8 variable. The total time. Sorry. You also learned how to display the content of the data set with a print procedure. Proc print data is equal to print.stack run. How SAS process program. When you submit a data step, SAS processes a data step and creates new SAS data. Let's say exactly what happens. The SAS data step is processed in two phases. New SAS data set, which is compilation phase and execution phase. The compilation phase is descriptor portion and the execution phase is the data portion. During the compilation phase, each statement is scanned for syntax error. Most syntax error prevent further processing of data step. When the compilation phase is complete, the description portion of the new data set is created. If the data step compiles successfully, then the execution phase begins. During the execution phase, the data step reads and processes the input. The data step executes one for each record in the input file unless otherwise direct. The diagram below shows the general flow of data step processing for reading new data. We'll examine both compilation phase and execution phase of this chapter. You have compilation phase, which is compile the program, and execution. Initialize variable, execute input, end of file, no, execute other statement, output to SAS. Start with the compilation phase. Input buffer. At the beginning of compilation phase, the input buffer is created to hold record from external file. The input buffer is created only when raw data is read, not when a SAS data set is read. So you have an input buffer. Program data vector. After the input buffer is created, the program data vector is created. The program data vector is the area of memory where SAS holds one observation at a time. The program data vector contains two automatic variables that can be used for processing but which are not written to dataset as a part of observation. Underscore and underscore counts the number of times data steps begin to execute. Underscore error underscore signals occurrence of any error that is caused during the data execution. The default is 0, which means that there is no error, which when one or more error occurs, the value is 1. Program data vectors underscore and underscore error. Syntax checking. During the compilation phase, SAS also checks statement in data step looking forward for syntax error. Syntax error include missing or misspelled keywords, invalid variable name, missing or invalid punctuation, invalid option. Dataset variables. As the input statement is compiled, a slot is added to the program data vector for each variable in a new dataset. Generally, variable attributes such as length and type are determined the first time as a variable is encountered. Data perm.update in file invent input total. Any variable that are created with an assignment in the data step are also added to the program vector. For example, the data statement below creates the variable tools. As the statement is compiled, the variable is added to the program data vector. The attributes of the variable are determined by the expression in the statement. Because the expression contains an arithmetic operation and produces a numeric value, total is defined as a numeric variable and is assigned default length of 8. Data perm update in file input total run. Descriptor portion of SAS dataset. At the bottom of the data stack, in this example, when run statement is encountered, the compilation phase is complete and the descriptor portion of the new set is created. The descriptor portion of the new set includes the name of the child dataset, the name of variables, the name of attributes of the variable, the SAS system, the content procedure, dataset name, perm.update, memory type, engine, dataset page size, number of dataset pages, maximum observation per page, and then you have variables and so on. At this point, the dataset contains 5 variables that are defined in the input data and assignments. Remember, underscore and underscore error are not written in the dataset. There are no observations because data step has not been executed. During the execution, each raw data is processed and then is written to a dataset observation. Summary of compilation phase. During compilation phase, the input buffer is created to hold a record from an external file. You have an input buffer, program data vector. The descriptor portion of SAS is created, SAS data partial, and so on. Execution phase. After the data step is compiled, it is ready for execution. During the execution phase, the data portion of the dataset is created. The data portion contains the data variables. Compilation phase, execution phase, new dataset. It's the same thing. The following data steps read value from the file invent and executes 9 times before there are 9 records in the file. Okay, initialize value 0, so it would be 0. At the beginning execution, underscore and underscore, because there is no data error, the value of error is 0. The remaining variables are initialized to missing. Missing name are represented by a period and missing character represented by blanks. In-file statement. The next in-file statement identifies the location of raw in-file. Data perm update in-file invert. Input item in stock, backward, total, and run. Program data vector. Input statement. Next, the input statement will record into file, then the raw data 1 to 15 as an assigned item in the program data vector. So it would come one by one. If it's missing, it would take a dot. Next assignment, execute the value for instruction added to produce the values for total. End of data space. Several actions occur. First value in the program are written at the output of first observation. Dataset perm update. This is just the data set going up and up. I don't know why they put so many pages here. The value and increments from 2 to 3. Control return to the top of data step and the values for item are reset to missing. And error 0. When reading the variables from raw data, SAS sets the value of each variable in type to missing at the beginning of each time of cycle with these expressions. Variables are named in a retain statement. Variables that are created in some statement. Data elements in temporary array. Any variables that are created with options in the file and in-file statement. Automatic variable. In contrast, when reading variable from SAS sets the values to missing only before the first cycle of execution data step. Therefore, the variable retain their values with the new values become available. For example, through an assignment statement or through next execution set or merge statement. Variables that are created with option set or merge also retain their numbers, the values from one cycle to the execution to the other. You learn about reading SAS dataset, working with arrays, and use set and merge on later chapter. Summary on execution phase. You have searched how data Step iteratively records data in the raw data. Now take a minute to review execution phase of processing. During the execution phase, variables in the program data vector initialize to missing before the execution of the data step. Each step is executed sequentially. The input statement read into the input buffer and the next record of the external file identified by in-file statement. Other statements can then further modify the current observation. The value in the program data returned to SAS dataset at the end of the session. The program returns to dataset. Now, end of execution phase. At the end of execution phase, SAS log confirms that raw data file loss can display the number of observation. Note 9 records were read from the in-file invite. Have 9 observation file. You already know how to display with the print statement. Diagnosing error in the compilation phase. Now that you know data is processed, you can misspelling keywords and data set names, unbalanced quotation mark, invalid option. During the compilation phase, SAS can interpret some syntax error such as keyword data misspelled, tag, if you cannot, and so on. Prints error. Compiles does not execute. Some errors are explained fully by the message of sender. Other errors are not easy to interpret. For example, because SAS statements are free format, you fail to enter SAS statement semicolon, SAS cannot detect that error. Diagnostic error in the execution phase. As you have seen, errors can occur in the compilation phase, resulting in data step that is compiled but not executed. Errors can also occur during the execution phase. The SAS detects an error in the execution. The following depending on type of error. A warning is given. Values are stored in the program and displayed in the log. The processing of the step either continues or stops. Suppose you misspell the file ref in the in-file name. This is not a syntax error because SAS does not validate the file that you reference until the execution. But during a compilation phase and during the execution, then it finds it. Because invent is misspelled, the data identified raw data is incorrect. Note, however, that variable defined as data. Incorrectly identified variable types another common error. As you know that the values of item are characters, suppose you forget to place a $sign after the variable name in your input. This is not a compile type because SAS cannot identify item type until data values are read. Invalid data type for item 7 when you have SAS log. Validating and cleaning data. Data error occurs when data variables are not appropriate for SAS statement and they are specified in a program. The SAS detects data error during the program execution. When data error is detected, SAS continues to execute the program. In general, SAS procedure analyze data, produce output, or manage SAS file. In addition, SAS procedure can be used to detect invalid data. Proc print, proc frequency, proc means. Print procedure displays the dataset showing the values for it number missing periods. So we have proc tables run. In output, you can see both have invalid G for gender and the valid for age. In both gender, frequency, one observation is made. Okay. This mean can also be used to validate data because it produces some result displaying the descriptive statistics. We're giving some hints on how to calculate the min, max, and other thing. Testing your program, limiting observation. Remember that you can use observation to limit the number of observations that you can read or create. When data steps create the program update says to variable with only 10 observations. The put statement. When source of the program error is not apparent, you can use put to examine the variable values and print out your message. For diagonal, you can use if-then statement to conditionally check for values. You can learn if-then statement, creating and managing variable. If type is equal to unknown, my known, invalid. Thank. Now in this example, if code does not have an expected value of 1 or 2, the put statement writes a message to the SAS log. Character string. You can use put statement to specify character string to identify a message in the log. The character string must be enclosed in quotation mark. Dataset variable. You can use put statement to specify one or more dataset value to be example for iteration. Like invalid value. Put my node invalid value, put type is equal to this. So they are talking about how to use it. Then you can do conditional processing. You can use a put statement with conditional processing, that is if-then statement to flag program error out of range. For example, the put statement is used to any missing zero, that is your rate. So if you have data finance.nuclear in file new loans, if rate greater than 0, then interest is, else put data error rate is equal to underscore n is equal to the put statement. The chapter shows where is the put statement. So this underscore and is like an ampersand that goes inside that. So this was a very quick summary of chapter 6.